Okay, we need to find the student's error and find the correct arc length. We've been given the formula here that S is equal to the radius times theta. I'm going to remind you though that theta in this particular equation has to be given in radians. Okay? Again, I want to remind you that while it is true that the entire distance around the circle is 360 degrees, when we're talking about radians, it is 2 pi radians the whole way around, okay? So it's 2 pi radians the whole thing, which means that if you've got this whole circle, if this is 10, the distance in radians from here over to here is going to be pi radians, okay? So pi radians, 180 degrees, yes, but pi radians. So I know that it's easier for you to think in terms of degrees because that's what you've been used to. So if you can think of this as 180 degrees, what fraction of 180 degrees is 60? Or can you change 60 degrees into radians? If you have 60 degrees and you have to change that into radians, I'll just say 60 degrees over 1, and our conversion factor for radians is 180 degrees over pi, or pi radians over 180 degrees. Notice the degrees cancel, and we're left with, well, essentially 1/3 pi radians, okay? So 1/3 pi radians, the units for radians just kind of come tagging along. So let's solve this problem correctly. The radius is 10, and so theta, the angle measure, is actually going to be pi over 3, okay? Now, if you do the calculation on that with your calculator, you should end up with 10.47 meters, which makes sense. If the radius was 10 meters, then this length here is just a little bit longer than the radius, okay? So what is the error? The error is the student used degree measure instead of radians, okay? And then of course the correct answer is right here.